That's not what this is. Okay? At this point in time, we have three different operations with fractions: adding, subtracting, and multiplying. Your openers can be any one of these three. And after tomorrow, you can do any one of the four, whether we're adding, subtracting, multiplying, or dividing. So you need to be able to read through a problem and ask, what is this particular problem asking me to do? Okay? Now, here's one of the things that I've noticed with fractions. Students struggle with them trying to determine what operations they are. And the biggest reason they struggle is because they're not used to the fraction idea. So here's what I always tell people. If you don't like the numbers provided in a story problem, then what you should be able to do is change the numbers and ask what you would do with those new numbers. And then whatever you do with the new numbers is what you should have done with the original. Okay? So let's just say this. Let's say for a minute that it takes 2 cups of sugar, okay, for each batch of cookie. How many cups would I need if I'm going to make 3 batches? Anyone?
6 cups.
6 cups. Miles, how did you get that? I just took 2 times 3. So if we would do that with 2 cups, what are we going to do with, we have 1 2/3 cups. Does the operation change that we would do? No. So do you see how you can change the problem and then say, well, consider this. If I'm going to multiply here, I should be multiplying here. So one way, and there's more than one way to do this problem, but one way to do this problem is that we are going to take 1 2/3 and we're going to multiply this by 3. This is what we worked on yesterday. Okay, the back page, we multiplied mixed numbers together. Okay, so first thing we do is we change 1 2/3 into a mixed number. So we take, into an improper. 3 times 1 is 3, plus 2 is 5. So this is going to take 5/3 of a cup, just for one batch. Now, we want a total of 3 batches. What did we say yesterday we're going to do with that whole number of a 3 to make this look like what we did yesterday? We're going to put it over 1. Because then when we put it over 1, we can follow the rule that we talked about yesterday, which is multiplying straight across. Top times the top and the bottom times the bottom. Numerator times numerator over denominator times denominator. So when I go to multiply these two straight across, I can either, again, reduce first and multiply second, or multiply first and reduce second. If I were to multiply first, 5 times 3 is 15, over 3 times 1, which is 3. Then I would reduce second. What's 15 divided by 3? 5. It's just equal to 5. Okay? Or, if I were to take my 5/3 and multiply this by 3 over 1, we could reduce first. So I can't reduce my 5 and my 1, but I can reduce my 3 and my 3. They're both divisible by 3. So when I reduce those each become 1s. We've got 5 times 1, which is equal to 5, over 1 times 1, which is equal to 1, and 5 over 1 is equal to 5. I don't know what it is, but I feel like today our focus is not up here at all. Let's take our heads up off our desk. Let's make sure that our cell phones are put away, our earbuds are out, and we don't need to be distracted by anything else. I feel like right now I'm fighting for your attention, and that should not be what I'm doing. Okay? And I'll be honest, we are in week 7 of school. The fact that I still have to ask for this is not okay. Some of you, it's every day. Take your earbuds out. Put your cell phone away. I don't understand why in week 7 we still have to be told that. Okay, now, the other way to do this problem would be to not even make it a multiplication problem. Okay, multiplying something by this 3 is the same as doing what? It's just adding it by itself 3 times. So let's say you were gone yesterday and you don't know how to multiply fractions. That doesn't give you an excuse not to know how to do this. What you're going to do is you're going to take 1 2/3, add 1 2/3, and add another 1 2/3. Now we know that we can add fractions by changing them again to impropers. 5/3 plus 5/3 plus 5/3. You already have a common denominator, which is required when you add fractions. 5 plus 5 plus 5 is 15 over 3. And 15 over 3 reduces to give you 5. Same idea. Now, if I was making 30 batches, then I'm probably not going to write this out 30 times. I'm going to do it as a multiplication problem. But remember, multiplication is just adding over and over and over again. Multiplying something by 6 is adding it to itself 6 times. That's all it is. Okay? So, either way, we end up with an answer of 5 cups. Now, here's the other thing that we need to start to be a little bit kind of, what type of answer should I get? Number 1, my answer should be a whole number in this problem. Number 2, tell me, think about a reasonable answer. Some of you, as you walked around, you got an answer that was smaller than 1. How, if I have 1 2/3 cups of sugar, and I'm making 3 batches, how can I have less than a cup of sugar needed? That's not reasonable. So just trying to guess on what we're doing and throwing it together, that's fine if that's the only strategy we have, but you should be able to problem solve a little bit and go, no, that's not reasonable. That's not going to work. Okay. All right, let's take a look at problem number 2. All right, problem number 2 says 3/4 of a pan of brownies is sitting on the counter. You decide to eat 1/3 of the brownies in the pan. How much of the original pan did you eat? Okay? I saw one person who I loved what they did. They drew a picture. Okay? And this picture really can be very, very easily done, and it's pretty intuitive to find your answer then. There's my pan of brownies. 3/4 of it is left. You ate 1/3 of it. Do you guys see how you ate 1/3 of the brownies? You ate 1/3 that was left, right?
Yeah.
How much of the original pan did you eat? How much is that? You just ate 1/4 of the original pan. You break it into fourths because that's what it was left. There was 3/4 left. Out of those 3/4, you ate 1/3 of that. Well, this is perfect because there's 3 pieces here. I had 1/3 of it. So now when I go back and look at the big picture, I ate 1/4 of the entire pan of brownies. No computation needed. Literally, you could draw a picture to help you with that one. Now, here's another strategy to use. What if I told you that there were, again, let's get rid of the fractions. There are 8 brownies, and you're going to eat half of them. How many are you going to eat? 4. What if you're going to eat 1/4 of them? How many are you going to have?
6.
You're going to eat 2 of them. How do you find these answers? What are you doing with these 2 numbers? You're not dividing them, because 8 divided by 1/4 is actually 32. No, 8 minus 1/4 is 7 1/4. You're actually multiplying. Because what is 8 times 1/4? Change that into a 1, right? That's 8 over 4, and what's 8 over 4? 2. Yep, thank you very much. So, do you see how you can get rid of the fractions, make them into numbers, determine what operation you need to do, and then plug your fractions back in? And you guys see how you can do this? This is a great strategy to use. Okay? So, if I know that I need to multiply these together, now I'm taking the 2 numbers they gave us, which is 3/4, and I'm going to multiply that by 1/3. If I multiply these together before I reduce, 3 times 1 is 3, over 4 times 3 is 12. But then I have to reduce this, because top and bottom are both divisible by what?
3.
By 3. So when you divide the top and the bottom each by 3, you're going to get 1/4. Or, you take 3/4 times 1/3, and you reduce before you multiply. You divide 3 by 3 to get 1. You divide this 3 by 3 to get 1. And now when you multiply straight across, you get 1/4. Alright, last one. Says, a recipe calls for requires 3/5 of a teaspoon of black pepper, 1/4 of a teaspoon of red pepper. How much pepper does this need? Well, first of all, what's the operation I should be doing with these two fractions? Should be adding them. Not multiplying them, not dividing them, not subtracting them. I should be adding these. Okay, again, if you need to, yes, you're not going to use 2 cups. But let's say you have 2 teaspoons of black pepper and 3 teaspoons of red pepper. You take 2 plus 3 and add them together to get 5 total teaspoons of pepper. No different here, except now you have fractions. We're going to take 3/5 and we're going to add 1/4. Now, here's the reason I did addition, and I caught some of you doing this. Yesterday, what was the rule when you multiplied a fraction by a fraction? You multiply it straight across. So you know what I saw people do today? That. That's not okay. What's required in order for you to add or subtract fractions? Common denominator. So it literally took us a day and some of us forgot that already. You got to know what you need to use when you've got to use it. So, common denominator between 5 and 4 is what? Is 20. Which means that you're going to multiply your first fraction by what? By 4/4. And your second one by 5/5. So this fraction will become 12/20. My second fraction will become 5/20. So when I'm done, I'm going to be left with 17/20. We would check to see if this can be reduced. We should be focusing on this, not on that. We're going to check to see if we can reduce this. Can 17 and 20 be reduced? No. There's my final answer. That's how many teaspoons of pepper we need for this entire recipe. Questions on these? Alright. Then let's take a look at your assignment from last night. I will go ahead and rewrite our mixed numbers up here as impropers in just a second. But you can get a start on checking through the rest of them. Now I will point out that in problem 21, you probably at some point need to be able to convert this back into a mixed number. Or at least a decimal to answer the question of whether or not there's enough paint. Alright, let's start taking a look. What do we got? Hi. Number 13. Alright, so for problem number 13, we are taking a negative 18, and we're going to multiply this by the fraction of 8/9. So first thing is make sure that when you are multiplying a fraction by a whole number, that you remember that you can change your whole number into a fraction by just putting it over 1. Then we can go ahead and we can use the rule that they talked about in number 1. You're going to multiply the numerators together, you're going to multiply the denominators together. Now, if you want to multiply first and then divide second or reduce second, that's fine. But some of you quickly found out like you got really, really big numbers. And this is again one of those strategies that like if you're not going to see it in practice, you're probably never going to do it. So I'm going to start reducing first. So, 18 over 1 can't be reduced. 8 over 9 can't be reduced. 8 and 1 cannot be reduced. But 18 and 9, those are both divisible by 9. So if I were to divide negative 18 by 9, that becomes what? Negative 2. And 9 divided by 9 becomes 1. So now when I go to multiply straight across, I'm going to multiply my numerators. Negative 2 times 8 is negative 16. Over multiplying my denominators, I get just 1. And remember what we talked about yesterday. If the answer shouldn't or doesn't need to be written as a fraction, then we don't. Okay, when you take your check tomorrow, you need to be aware of that. Take negative 16 divided by 1, and we're just left then with negative 16. Okay? Next question we've got. Megan, number 11. Number 11 says we're taking negative 35 over 38. And again, I'm going to put the negative with the top right away. Negative 35 over 38. And we're going to multiply this by the fraction of negative 19 over 40. First thing, what do we know? A negative times a negative is going to be a positive. So my answer had better be positive. Okay? Now, here's a perfect example. You're going to get really big numbers really fast. Let's reduce first. Somebody tell me a number that goes into a number on top and bottom. 5 goes into both of these. So if I were to take negative 35 and divide by 5, that leaves me with negative 7. 8 divided by 5 is, or 40 divided by 5 is 8. Any other common factors? Yes. 38 and 19 are both divisible by 19. So 38 divided by 19 is 2. Negative 19 divided by 19 is negative 1. Do a lot of reducing before we go ahead and multiply. So now when I multiply negative 7 by negative 1, that gives me positive 7. And 2 times 8 is 16. There's my final answer, 7/16.
So one of the things when you have a prime number like 19, always just try it, right? Because a lot of you guys just thought like, oh, it's prime, it's not going to work. Well, you can multiply prime numbers. They have multiples also.
Yep, and 38's not prime. So yes, always check in to see if you've got common factors there. All right, let's keep going. Hayden, what else? Number 3. All right, now this one we talked a little bit about yesterday in class. Because a lot of us were like, what am I doing with this exponent? Again, what does it mean to square something? Times it by itself. So if you're confused with the way this is written, that's fine. Rewrite what it means. This means to take 3/4 and multiply it by 3/4. Now, I can't do any reducing. My 3 and 4, my 3 and 4, my 3 and 4, my 3 and 4, none of that can be reduced. I just multiply straight across. We're taking 3 times 3 to get 9, 4 times 4 to get 16. There's my final answer of 9/16. All right, what else do we have here? Quentin?
17.
Number 17. Number 17 gave us 2 mixed numbers and asked us to multiply these together. So we're taking 6 and 1/14, and we're multiplying this by 6 and 37 over 51. All right, So we want to make sure, first of all, we've changed these into impropers correctly. 6 times 14 is 84, plus 1 is 85. If somebody double checked me there.
Yeah.
That's 85 over 14 though.
Yeah.
Okay, 6 times 51 is 306. We're going to add 37 to that, so we should get 343. Does that sound right?
Yeah.
Over 51. Now, again, I'm not going to start off by multiplying there. You're going to get really large numbers right off the bat. Now, this can't be reduced. Again, here's my suggestion. I know this can't be reduced because this fraction here couldn't have been reduced. If 1 over 14 can't be reduced, then when I change it to an improper, that also can't be reduced. Okay? 37 and 51 can't be reduced. This is not going to be able to be reduced. But, somebody double check me here. I don't know, I'm trying to remember. Does 17 go into 85? Does 17 go into 51? Yep, let's reduce there. 85 divided by 17 is? 51 divided by 17 is? 3. See how you made your number smaller already? 14 and 343. Now 14 doesn't have a ton of factors, but one of those at least goes into this. What is it? 7. This divide by 7 to get 2. This divide by 7 to get 49.
I was just going to mention that if you didn't reduce all the way on something, you can always look at those numbers one more time and make sure nothing else is divisible.
Correct. Now, 5 and 2, this is what Ms. McClure was just talking about. 5 and 2 can't be reduced. 49 and 3 can't. 5 and 3 can't. 2 and 49 can't. Now I know I'm reduced. So now when I multiply these together, 250, so 245 on the top, over 6 on the bottom. Now, I'm going to be honest, when it comes to reducing fractions, you might say, well, Mr. Tompkins, how are we supposed to know 85 and 51 are divisible by 17? You don't until you practice it. And until you practice it and get good at it, you're not going to recognize the shortcuts. So you're always going to default to the long way of doing problems. It's kind of like adding and subtracting fractions. Some of us have just learned that you multiply by the other denominator. That's fine, but you're always going to take the longest route to get there. I can't teach you the shorter route until you start to get the number sense down. This goes into this. This is a factor of this. That's stuff that's just gotta, I'll be honest, like, it just comes with practice. And if you don't practice it, you're never gonna get it. Alright, any others that we have in the homework? Again, I'm gonna talk about 21 here real quick. If you found the area of the wall, which is what part A asked you to do, okay? Making it this number is great, but it doesn't answer part B. When part B says, if you bought 200 square feet of paint, is that enough? You need to either convert this into an mixed number, which is what they've done here, or you need to rewrite 200. Here's the other thing most people don't think about. You need to write 200 as a fraction over 16. You guys do know that you can do that, right? Because then I can compare this number with this number. You might say, well, Mr. Tompkins, I don't know how to do that. Yeah, you do. Because all you're doing is writing this as an equivalent fraction. If this right now has a denominator of 1, what do I need to multiply by to make a denominator of 16? Need to multiply by 16, top and bottom. That becomes 3,200. If this is how much paint I bought and this is how much I need, do I have enough paint? Yeah, I do. But do you see, you got to be comparing things on an equal basis. I can't compare an improper to a whole number. I need to either have a whole number with a mixed number, or I need to have two fractions that have the same denominator. Otherwise, you can't tell me which number is bigger than any others. And let's face it, that's where fractions are going to come into play. how much paint do I need for this particular wall? I'll be honest, when you actually start to do that, you'll be like, I'll just go back and buy more. After your 7th trip to Home Depot buying extra paint, you're going to get sick and tired of it. So when you walk in and say, hey, how much paint do I need for this? How many gallons do I need to buy? What's the first question they're going to ask you? How much are you painting? Well, I'm painting my bedroom. That's great. How big's your bedroom? Is it 10 by 10? Is it 12 by 12? Is it 16 by 16? Do you have 8-foot walls, 9-foot walls, 12-foot walls? Because all houses aren't the same. So you're going to need a lot more paint if I've got a 12-foot ceiling as opposed to an 8-foot ceiling. I can't just walk in and they're going to tell me the answer. I have to be able to figure it out. Alright. A 7th period today. We have a check that we still need to go over. I got that graded and turned in. Graded and scored, put into the grade book yesterday. We got a lesson to teach. A quick reminder for RTI students that I'm not reminding you, you are checking for RTI. I already had someone yesterday who didn't show up. And I know the easy excuse is, I didn't know I had it. I'm not going to remind everybody. I've been trying to put it in a couple days ahead. I'm not going to have on Tuesday, I need to talk to these people. It's already there. You simply need to check.